my great pleasure to introduce Mike again today. I want to just say a few words because I didn't get long enough to talk last night since I'm not a professor anymore. So all of you have seen this poster of Albert Einstein with the Think Different bubble over his head. And if there's anybody in our community that over a career of 40 years plus has thought different, it's certainly Mike. And last night I hinted about what Mike was doing in grad school. Well, to be a little more specific, Mike's thesis was in discrete stochastic processes. He graduates, he goes to Berkeley, which is not a second-rate school in engineering, and he starts doing databases. Now, he's never seen a database. Nobody had built a relational database system before Mike and the System R team, the English team and the System R team built one. But that's an example of Mike thinking different. If you've read the Mariposa paper, that's an example of Mike thinking different. Adding type extensibility to Ingress in the 84 paper, thinking different. Column stores, thinking different. So Mike over and over has exemplified thinking different. But when it comes to Turing Award, Mike also had to think different too. So the classic Turing Award lecture is some boring, repetition of your life's work. And the classic Turing Award paper that'll come out in CACM is the same. Mike had to think different. And it's caused a bit of problem with the Turing Award hierarchy inside ACM that Mike has written a very controversial paper that ACM has dragged its feet on publishing. And we're going to try to make copies available to you. But, and I think, I saw the paper when it was the first draft came out. I think it's a wonderful story. And I hope when you get a chance to read the paper, you'll read it a couple times and think about the lessons Mike is trying to teach you in this paper. And he's going to talk a little bit about it today, but it's truly a different take on a Turing Award lecture. It's my great honor to introduce Mike Stonebraker one more time. Please, let's have a round of applause.
So thank you, David. At least you didn't say you know more about software than I do. Okay. So the land sharks are on the squawk box. Illustra, which is the commercial Postgres company, is a year old, and we are down to fumes. We're running out of money, and it's fallen to me to negotiate another infusion of capital from our venture capital backers, who I affectionately call the land sharks. They are on a Polycom in venture capital heaven, which is 3000 Sand Hill Road in Menlo Park, California. Unfortunately, I'm at my brother's fishing cabin in Maine for a family event. There are 8 of us crammed into the thing you see on the slide, and this is before the days of cell phones. So there's a single wall phone, and the cord is stretched from there into the bathroom where I'm trying to negotiate a deal. The land sharks negotiate deals every day. I negotiate them a few times in my life, and so I feel at a huge disadvantage. And the conversation is depressingly familiar. They say more stock, lower price. I say less stock, higher price. Eventually we reach a deal, and Illustra will live to fight another day. What I'm going to talk about today are an interleaving of 2 different stories, and I will try and draw parallels at the end. The first one, which is in green, was a cross-country bicycle trip that my wife Beth and I did in the summer of 1988. The blue one is the design, construction, commercialization, and eventual sale of Postgres/Illustra, which occurred over 12 years from the mid-'80s to the mid-'90s. Both of these projects started off on a real high point. Here Beth and I are in June of 1988 at the ferry terminal in Anacortes, Washington on Puget Sound. We are on our brand new tandem bicycle. We are about to start riding east up the North Cascades Scenic Highway. Our destination is Boston, some 3,500 bicycle miles away. It doesn't faze us in the least that we've never ridden a tandem before. We are equally unfazed by the longest bicycle trip either of us has ever taken has been 5 days. And we are nonplussed by the fact that we have never ridden mountains like the ones directly in front of us. Moreover, we have an 18-month-old daughter who is going to spend her summer on the road, and we just assume that that's going to work out okay. We are starting out on a great adventure. We are really in high spirits. Well, in 1984, in Berkeley, commercial Ingress, which was started in 1980, is now 4 years old. In the academic code line, we are continuing to prototype new ideas on that code line, but it's getting to be ridiculous to work on a code line that is now vastly inferior to the one the commercial guys are using. So it really makes no sense to continue prototyping on the academic code line. I make the painful decision to push that code line off the cliff and start all over again with a clean sheet of paper. So that's the start of Postgres. So what is Postgres to be? Well, I had been around, as DeWitt said, in the 70s. Ingress and System R were the main relational prototypes, and they were completely focused on business data processing. We are trying to beat IMS and Codicil, which was the competition, at what they were good at, which was business data processing. So both systems were completely focused on business data processing, and so by the early 80s, there were quite a collection of papers of the following form. There's this great new stuff called relational database systems. We tried it on problem X, and X could be geographic information systems, computer-aided design, library card catalogs, and invariably it didn't work. So we propose adding Y and pick some extension to the relational model. It was really clear to me that if we did all of this, that it would be the death of relational database systems by 1,000 uncorrelated extensions. So you had to do something better in order to address non-business data processing markets. So we, at the time, there was a GIS group down the hall which was trying to use Ingress. So we used that as an example. And we're up against the following problems. So let's assume we'll have the standard employee database. We'll give employees a name and an age. And then let's suppose we have the size of their parcel of land where they live. And we'll square it up to be a rectangle so it's not a polygon. Otherwise, that would really be hard. So here we have an employee named Sam, who euphemistically is 38, and we'll give him a rectangle, which are the other 4 fields. That advanced by itself. How come you can't go back? You said your machine was better than mine. Okay. Stop. Okay, so and the coordinates of your box could be floats, integers. They were supported at the time by Ingress and System R. And so one of the things that you have to do if you want to get a zoning variance for doing something different on your parcel is that everybody within a certain distance has to be notified that you're doing something that's not approved, and they get a chance to object. So what that is you need to find all the parcel owners which overlap a rectangle, which is the enclosing thing around your parcel. So basically you're trying to do rectangle overlaps rectangle, and the code in sort of bastardized SQL is at the bottom of the slide, and somebody in the audience will almost certainly tell me it's not right. I can assure you that it is right, although you have to think about it for a while to make sure that that's true. So this is kind of messy, it's difficult to understand, and it's pretty difficult to optimize because it's a bunch of one-sided inequalities. So this is about the simplest geographic query you can think of. And so this was hard and difficult to optimize. So something is clearly wrong. And what's obviously wrong is that business data processing said, let's have strings, floats, and integers as the data types. And that's not what you want in geographic information systems. You want things that are rectangles for this particular example. So I'd rather have exactly 3 columns, Sam with his age, and then I'd like location to be a geographic rectangle, and the representation of that rectangle is some bunch of bits that get stored in that field. With that new schema, the query you want to run is, I want to find the names of employees whose location overlaps, make a box out of the geographic coordinates of the box I'm interested in. So that query is now obviously correct, and all this requires is user-defined data types, whatever ones you want, in this case rectangles, user-defined operators, in this case overlaps, and user-defined functions. I need to make a box out of a bunch of integers or floats. So this requires adding functions for overlaps and make box to a database engine and then calling them at appropriate times during query execution. So this is pretty straightforward conceptually, but the devil is in the details. If you want to make GIS go really fast, you need geographic indexes, things like R trees. You certainly need to be able to use new types in normal indexes, think B trees and hashing. You got to teach the query optimizer about these extensions. You got to deal with commutativity rules. SQL engines all optimize the not operator, so you got to deal with that, ... So the devil's in the details. The idea seems like it's a good one, and it fell to us to try and fill out the details. Here we are in Winthrop, Washington. I am really in high spirits, even though my legs are throbbing from the hips down. I'm standing here with Mary Ann, who is our sag wagon driver and babysitter, along with our 18-month-old daughter, to prove to you that she was really with us on the road. Why am I so uptone? We started off at 5 o'clock this morning from Devil's Lake, Washington, and telephone pole by telephone pole, we struggled uphill for 50 miles. Over the course of that distance, we rose 5,000 feet into the Cascades. It got really cold. We put on every piece of clothing we'd brought with us. And even then, it started snowing, and we were really unprepared for trying to ride uphill in the snow, something I've never done before. Eventually, we get to the top of the aptly named Rainy Pass, and here we are sort of getting off our bike and getting a picture taken by some innocent bystander. After a short downhill, we have another 1,000 feet to climb to the top of Washington Pass. And finally, after that, there's a glorious downhill into Winthrop. So I'm elated. Why am I elated? Well, we're over the first two mountains. There are a whole bunch in front of us, but we've proved we can do the mountain passes, and life is really looking up. Well, in 1985, Chris Date had written his pioneering paper on referential integrity. It appeared in 1981. And basically, it's what to do if you have foreign key, primary key constraints. So just for example, here's the traditional standard example of employees and departments. So we have 4 employees with names, departments, salaries, and ages. We have 2 departments, the shoe and candy department, along with a bunch of attribute data on them. And notice that art is in the candy department. And so what happens if we run a SQL delete that gets rid of the candy department? So we're left with a dangling reference in the employee art. And what do we do? Obviously, following that pointer will generate an error. So Date's solution was to propose all the reasonable options. So if you delete the candy department, the first thing is cascade the delete, which is fire all the employees who are in that department. That gives you a consistent database. Second thing he said was, well, you could also replace the candy department by null. That will give you a consistent database, which is now the people previously in the candy department are now in limbo. And the third thing you can do is refuse the delete, saying it's going to create an inconsistent database, so just refuse the delete. There are 3 corresponding actions on inserts, and that was Chris Date's solution, which had generated by that time a lot of acceptance in the commercial marketplace. So the problem that to me was, well, we had to deal with referential integrity in any new system. That was kind of table stakes for building anything. By then, there was also a fair amount of interest in triggers. So if you had 2 employees, Sam and Bill, and you wanted to make sure that if Sam ever got a raise, that raise got cascaded to Bill, well, that requires a trigger. And that's different than referential integrity, but just another action that has to be done as a side effect of an update. The third thing that was true at the time was integrity constraints. Things like salary has to be non-negative. And that required another set of actions to be taken as a side effect of updates. So you look at this for a minute and you see sort of 3 different little bitty rule systems. And the idea was, this is going to be complexity in spades if we keep implementing all kinds of little special purpose rule systems. So my idea was to say, let's try and build a single rule system that can do at least all 3 of those things. Well, you're right up against the general purpose rule systems at the time. I hated them all. And the problem is rule systems fundamentally have squirrely semantics. So let's start with our employee, George. And let's assume we age him from 39 to 40 years, and we have 2 rules that are on the slide. Well, if I run the first rule, well, whatever department George is in, he'll get put in the shoe department. And then the second rule will fire, and he's now over 40, so he ends up in the candy department. So that's one possible outcome, is George is in the candy department. The other outcome is to say, well, I aged George to 40 years old, and I run the second rule first. That says move everybody over 40, and that includes George from shoe to candy, so I put him in the candy department. Then I run the first rule, which replaces him back in the shoe department. So if you run the rules in the opposite order, he ends up in the shoe department, and I get an order-dependent outcome. And it's sort of death to relational database systems who are trying desperately to do set-oriented updates without them being order-sensitive. And here was an obvious order sensitivity that was really going to create a mess. This was also about the time of the Japanese fifth-generation computing proposal, which said, let's write everything in Prolog. And so there were a whole bunch of, a lot of interest in Prolog. And we started handing around 20-line Prolog programs. And no mere mortal can pick up a 20-line Prolog program and figure out what it does. So rule systems are inscrutable and they're order sensitive, and that just seems that that can't be the right way to run a railroad. So after thinking about it for a long time, like a year, I said, well, the best thing I could come up with is to add a keyword to update commands, which was called always. So if you tagged an update with always, then it would have the semantics that it appeared to be continuously running, simply always running. Of course, that's not the implementation, but that's the semantics. So the command appears to be perpetually running. So if you want Bill to have the same salary as Sam, well, the update command sets Bill's salary to Sam's, and then you just say always, and that will then make it always true. So this is somewhat cleaner than an if-then rule system, and at least it was something a little different. So that was what we were going to bet on, was an always tag to update commands. Here Beth and Leslie and I are at Marias Pass, Montana. This is day 15. This is the Continental Divide. It's a beautiful day, and we are absolutely ecstatic. The endless climbs and the Cascades and the Rockies are all behind us. The Great Plains stretch out in front of us, and more importantly, it's downhill to Chicago. Third thing that Postgres was going to bet on was all of us in the 70s had figured out that you had to do crash recovery. So the adage in database systems is never lose my data, and you have to take that seriously. So the way everybody did it at the time was that your picture would be a database system managing a thing that looked like a disk, which said data, and that was the database as you thought of the database. But that's actually not the database of record. The database of record is the thing on the right, which is the log. So every time you do an update, you write the way the data used to look in the log, the way the data is about to look in the log, and you have two different data stores, one managing the log, one managing the data, and those have to be very carefully synchronized. Sort of Mohan wrote this down as write-ahead logging. Aries was the traditional wisdom on how to do this. And the thing I had figured out by then is that log code is complicated and ugly, and it has to work. The thing that really gets you in trouble is if an important customer crashes, you run the log code and the log code fails, then he can't restore his database, and you are in deep doo-doo. And if he's an important enough customer, you end up on the front page of the New York Times. So here is log code, complicated, ugly. This is a database on the side, which is the system of record, and it's absolutely got to work. So you say, there's got to be a better way to do this. So the first thing that comes up to think about is to say, well, the only reason you need all this stuff is if you give Sam a 10% raise, if you overwrite his record in the database you think of as the database, then you've got to write a log of the way his data used to look in case you have to back it out. And you have to also write the way it's going to look in case you get a hard crash. So suppose you just don't update his record in place. You just leave it where it is, and you write a new record with the way it's going to look. So that means that the log is just wound in with ordinary data, and it pretty much gets rid of crash recovery code. In addition, since you have to timestamp the way it used to look, the way it's going to look, you get time travel for free. You can keep around old records for as long as you want, and life at least looks interesting. And if my phone would please stop ringing, that would be a good thing. By the way, I play the 5-string banjo. This is my banjo. So anyway, so this seemed like a good idea, but of course the problem is the devil is in the details. So when you think of the data in the database, you think about indexing and clustered indexes, and you carefully try and optimize data placement for read so that queries go fast. On the other hand, the log is something you write at commit time, and invariably it is written sequentially so that it's write optimized. If you're only going to have one data store, then you've got to be very clever in order to get high performance. This is a tricky placement problem where to put stuff. So at least this was something that was interesting to try and make work well. So the Postgres game plan circa 1986 was we were going to bet on abstract data types. That seemed like a good idea. We're going to do rules using this always command, and we're going to leverage no overwrite storage. So that was Postgres's game plan in a nutshell, and that was what we set out trying to make good on. There was a bunch of other stuff in Postgres, but in my opinion, the top 3 things were what was important. Well, we started off in both of these endeavors on a real high point, and that didn't last long. So things aren't going so well on both the bike ride and on Postgres. So we'll now turn to the first speed bump for both of these endeavors. We hit North Dakota, and here is a picture of us entering the state from Montana. You don't see any trees. Beth and I joke that the state tree in North Dakota is the telephone pole. The landscape is forlorn and bleak, and we endlessly, up ahead you'd see the next grain elevator, which signified a town. You'd ride toward the town for an hour. You'd pass through the town in a few minutes, and up ahead you'd see the next grain elevator. So we had seen that for several days, and that was certainly getting forlorn and bleak. But that really wasn't what was killing us. We were expecting to sort of sit up straight in the saddle on Boston bound and get blown across the state by the howling winds that go across the Great Plains. We were expecting to make 16, 18 miles an hour with easy riding. Well, that's not what happened at all. It turned out that the summer of '88 was weird weather in the upper Midwest. The wind was howling all right, but it was howling east to west. We were riding straight into gale force winds. So we were struggling hard to make 7 or 8 miles an hour. This all came to a head in a place called Drake, North Dakota, which is about halfway across the state. Beth and I are just incredibly depressed. The wind has been howling all day, and it was all we could do to make 50 miles that day. Our target had been to ride to a place called Harvey, which was an elusive 25 miles further on, and we were not going to make it. It was all we could do to refuse a ride from a pickup truck who offered to transport us down the road. So, worse yet, it's still 250 miles to the tree line and the Minnesota border, and I have no idea how we're going to get there. Well, in Postgres, reality sets in a big way. First of all, we had written Ingress in C. C++ wasn't really ready yet, and so we drank the AI Kool-Aid and we started writing Postgres in Lisp. This was an unmitigated disaster. Lisp was an order of magnitude slower on absolutely everything. So a huge amount of code got thrown over the cliff, one of many rewrites along the way, and we converted what we could to C and rewrote the rest. So that was just a disastrous experiment in new languages. The abstract data type system was looking promising. That was a real high point. The way I knew that is that I was in parallel the chief technology officer for Ingress, and I got a call from an Ingress user in New York City right after Ingress had implemented date and time as a data type according to the ANSI specifications. This user promptly explained to me that we'd implemented date and time wrong. And I said, oh, we implemented the Julian calendar just like it says to do in the specifications. And that says that if you subtract April 30th from May 30th, you get 30 days. If you subtract February 15th from March 15th, you get 28 days, except during leap years, except during double leap years. We implemented exactly what the specs said. But this user said, well, that's not what I want. It turns out that he was implementing an application that computed interest on financial bonds. And it turns out that in the US, for God knows what reason, you get the same amount of interest during each month, regardless of how long the month is. So the Wall Street guys think of the calendar as divided into 12 equal length months, each 30 days long. So March 15th minus February 15th is 30 days. Thank you very much. So this customer said, all I want to do is get rid of your implementation for minus on date and time and replace it by mine. And that would make my application go 3 times faster because I wouldn't have to copy stuff out to user space and all that. And the ADT system, that was child's play to the Postgres ADT system, but of course you couldn't do it in Ingress or any of the other relational database systems at the time. Since then, there are just all kinds of semantics for time. 2-day delivery, if you're FedEx, doesn't count Sunday. So 2 days from Saturday turns out to be Tuesday. And so people have all kinds, and trading days only count trading days, they don't count calendar days. So there's lots and lots of semantics for time, which could easily be done by Postgres. Time travel has interesting promise, but we can't figure out how to get it to run fast. And that was a problem that would elude us indefinitely. The always command doesn't work. The game plan had been it's got to at least do all 6 cases of referential integrity, and we couldn't figure out how to do that. So after trying for a year, we give up. A lot of code goes over the cliff, and we go back to square zero and start exploring more conventional rule systems. So over the next 3 years, the wine connoisseur, my partner and I, spend a lot of time slogging through the swamp. There was a lot of repair, which was how complex can complex objects be, what to do about time travel, what to do about a rule system. We struggled for 3 years trying to make good on the original ideas in Postgres. So life is not looking very good in either of these endeavors. But of course, bad things don't continue forever, usually. So what happened with the bike trip? This is the next day. We are in Carrington, North Dakota. And serendipity has set in a very, very big way. God was on our side that day, and it doesn't have anything to do with the wind. The wind is still howling in our face just like it's been all along. Serendipity is my brother, shown here in this slide. Notice the bleak landscape, that never changes. My brother has decided to come out and ride with us for a week. And Marianne picks him up at the Minot, North Dakota airport, he and his bicycle. And he is very, very strong and is fresh and hasn't been beaten down by the North Dakota winds. So this whole day, he agrees to break the wind for us. Just like you see in the bicycle races, we try and ride 3 inches behind his rear wheel. It took a bunch of on-the-job training and a few excursions into the wheat field when we hit his rear wheel. But after a while, we get the hang of it, and trying to communicate with Beth faster, slower, we ride 79 miles to Carrington, North Dakota. And what's really clear now is that we are over the hump. We're going to get out of North Dakota 3 inches behind my brother's wheel, if necessary. Well, we finally get Postgres to a reasonable state. My non-compete clause with Ingress is over. And so we decide to form a commercial company to try and commercialize Postgres. The reason to do this is that, in my opinion, the ultimate arbiter of good ideas is the commercial marketplace. It's the only way to tell whether the rubber meets the road or the rubber meets the sky. If you want to make sure that your ideas actually work, then the arbiter of that is the commercial marketplace. So we decided to do a startup. If you want to do technology transfer, you certainly have 2 ways to do it. The first way is convince some existing commercial company to adopt your ideas. We had a ready candidate in Ingress Corporation. However, they had their own agenda at the time. And in addition, there's a fabulous book by Clayton Christensen, who's on the faculty at the Harvard Business School, called The Innovator's Dilemma. Basically, he says that if you're the company that's selling the old technology and you want to morph to the new technology, that's extremely difficult to do without losing your customer base. So if I'm a purveyor of the new technology, the people with the old technology are not going to be very receptive by and large. So in my opinion, the best thing to do is a startup, and that's exactly what we did. So I recruited Mom as vice president of engineering, and her husband, who is a brilliant coder, who I'll call the short one. EMP1 and the quiet one came over from the academic team, joined shortly thereafter by Triple Rock, and we had a fantastic core engineering team with my friend the Tall Shark as interim CEO and lead investor. We were off and running. We had some money. We had a game plan. You had to convert the query language Quell to SQL, which was the intergalactic standard by then, harden the code, improve performance. We were off and running, and with almost any startup, it starts off in a honeymoon phase with everybody on a real high. The high continues on the bicycle trip for a while. Here we are just having gotten off the ferry across Lake Michigan from Wisconsin to Ludington, Michigan. We are now less than 1,000 miles from Boston. There are no more bodies of water to cross. The upper Midwest and its endless expanses are behind us, and it's beginning to look like we're going to make it. In the Illustra project, after a couple of miscues, we get our permanent name, Illustra. We got the first few customers, which is the first thing you have to do as a commercial entity. We raised some more money when we ran out of money. Remember slide 1 and Kennebago, Maine. And most importantly, we hired an executive team. We hired the voice of experience as CEO, Uptone as the VP of Marketing, and Smooth as the VP of Sales. We had a real management team. Mom was cracking the whip over engineering. Things were really looking up. We were whipping the Illustra code into shape. So life is good. But of course, that doesn't last long. So both projects, hit another speed bump. So here we are at day 49. This turns out to be Anacortes, New York, on the state line between Pennsylvania and New York. Today was not a good day. For a starter, in the hotel in Corey, Pennsylvania, wearing bicycle cleats on marble floors is not a good idea. So I slip and wrench my knee. So there are only 3 good legs pushing Boston bound along. But that wasn't the worst of the problems. We've hit the Allegheny Mountains. We've been cruising along through Ohio and Michigan, Wisconsin, and it's been pretty flat and easygoing, and all of a sudden that's over. The Allegheny Mountains are up and down the same 500 feet over and over and over again. Moreover, road planners around this part of the country don't believe in switchbacks. So it's straight up and straight down, and we shift to the lowest of our 21 gears to get up some of these hills. It's exhausting riding, and we are not happy because the Alleghenies go on for quite a while. So in Anacortes, when Beth puts Leslie to bed, I go buttonhole the innkeeper with the following simple question: how do we get to Albany without climbing any more hills? Well, out of nowhere comes Illustra's first serious crisis. After the first few customers, what ends up happening is the next round of customers do not want data type libraries from us. So we had written a GIS type library. It worked great. Triple Rock, understood GIS pretty well. But the next round of customers didn't want our ADTs. They wanted them from the major GIS application vendors, people like ArcInfo and MapInfo. So customers wanted ADTs from third parties. So we made a pilgrimage to Redlands, California to talk to ArcInfo, Jack Dangerman. And he looks at us in the eye and says, we make the pitch saying, boy, your code will run a lot faster. It'll be integrated with database systems. Life will be great. He looks at us and said, I don't care. How many customers do you have? And how many more ArcInfo licenses am I going to sell? So he viewed us as a distribution channel, not as a fundamental technology shift. So we had a catch-22. The customers wanted stuff from the app vendors. The app vendors wanted customers. And we were contemplating this disastrous turn of affairs when the next crisis occurred. So we were trying to figure out how to get app vendors interested. You can't really bribe them because you don't have enough money. And anyway, most of them aren't really bribable anyway. So sales are not going well. So that created the next crisis, which is the dreaded down round. Now, the way startups work is that you start off at time 0. You negotiate with the venture capitalists. This is a zero-sum game across the table, and if you win, they lose, and vice versa. It's a zero-sum game. So you get through that, and you now have the initial deal. And that means a certain amount of preferred stock at a specific price. Then the idea is that when you run out of money, you raise more money at increasingly higher prices because you make forward progress, your company's worth more. Often the idea is that you get a new investor to set the price. The current investors are happy to support you, and you raise more money at increasing valuations. You get diluted, but the dilution is in general tolerable. But what happens if you cannot find a new investor to pay more money than the last round? Or what happens if the current investors say, I don't think the company's worth even as much as it was the last round because things are not going well? So that's what happened, which is the existing investors said, we'll support another round of capital, but at a lower price than last time. This is called a down round, and it's a fate worse than death. Why is that? Well, as you can imagine, it's very dilutive. But worse than that, there's a clause in almost all contracts between the land sharks and the entrepreneurs that say if you get a down round, ex post facto, you have to reprice previous rounds down to the current round. So that makes it doubly dilutive. So we're facing a down round, and the standard wisdom for the employees is to say, we're being diluted off the face of the earth here. We're not willing to continue working on this, on this company because it's not interesting anymore. So what ends up happening is you end up renegotiating the entire ownership of the company between the new investors, the existing investors, and the employees. This is really ugly and something I never want to have to do again. This takes us about 3 months. At the end of this 3 months, we've lost sort of 3 months of forward progress. What's more, by and large, the employees have been made whole. The percentage ownership of the investors changes, but not a whole lot. And they're engaging in some sort of strange game with each other that I don't really understand. But at the end of the day, we have more money, and Illustra will live to fight another day. Well, speed bumps don't last forever. So we left off with the innkeeper about to tell us how to get to Albany. And that should have been obvious to us. It certainly should have been obvious to anybody who was trying to move goods from the eastern seaboard to the middle of the country in the 1800s. The innkeeper says, ride straight north to the Erie Canal and hang a right. And that's exactly what we did. We cruised down the Mohawk Valley, and here we are at the Massachusetts border, and things are really uptone. All we have to do is get over the last hill, which is climb the Berkshires, and then it's easy going to Boston. Well, serendipity comes out of nowhere for Illustra. So this is right at the time when the internet was taking off. This is when Bill Gates goes to Cornell, gets internet religion, Netscape is going crazy. So the internet is taking off. Uptone, our marketing guy, turns the company on a dime. We are no longer about type extension or any of that stuff. We become the database for cyberspace, capable of storing all your internet data, images, geography, text. Moreover, he gets us included as the database behind a marketing project from a bunch of photojournalists called 24 Hours of the Internet, which is a worldwide effort to build a website every hour for a day. That gets a lot of buzz. We're the database system for that project. We're the database system for cyberspace. We get a lot of buzz. Sales and interest in the company starts to pick up. Maybe, just maybe, we've turned the corner. What's more, one of the internet giants of the time decides they might consider putting us into their system, which would be a company-making transaction. Of course, we're going to get baked off against all the other relational database vendors, but maybe we have turned the corner. There's a possibility for a company making transaction. Well, we don't actually get to the end without another speed bump. So here we are with Illustra again. And unfortunately, this internet vendor, instead of having a benchmark that tried to do image content or retrieve text or retrieve geography, which is the stuff we were really good at, he said, well, I'm going to bake you off on TPC-B, which is cash a check. Standard business data processing, transaction processing. This was the stuff that the then relational vendors had spent a decade getting very good at. We'd never worried about transaction processing. We were worried about new kinds of data, not at trying to compete head-to-head with the existing vendors. So transaction processing is not in our wheelhouse. We're going to lose this benchmark, and we're going to lose it badly. What's more, it's pretty obvious that what we're going to have to do is improve transaction processing performance a lot, and that's going to be a lot of work, mostly because of a bunch of decisions that I'd made almost a decade earlier on how to architect Postgres. So we're now staring into the abyss, which is the internet vendor says that inside every internet problem, there is a transaction processing problem, and you have to be good at that, and the other stuff is just gravy. So we're good on the gravy, but we're not good at transaction processing, and getting the system to be good at transaction processing is going to be a major rewrite. And so there's a pit in my stomach as we contemplate the future, and it does not look good. Well, this story now ends on a high point in both of these endeavors. So we crossed the Berkshires, and now we're only 175 miles from Boston, and we're actually contemplating how are we going to find the Atlantic Ocean, certainly not in downtown Boston, and how are we going to drag our bike out to the ocean and dunk the front wheel in the ocean, which is the way you have to end. So we elect to shoot for a place called Wollaston Beach, which is about 10 miles south of Boston. Here we are, and our trip is over. We repair to a a seaside cafe. We drink a glass of champagne and contemplate what to do next. Well, doom and gloom for Illustra turned out to have a silver lining. Serendipity occurred, which was soon after this bake-off. One of the major DBMS vendors that we had been competing against on this benchmark elects to buy us. He realized that the stuff we were good at was in his future, and he didn't want to write it all, so he elected to buy us. This was total serendipity. First of all, he had a big customer base, which meant it solves the catch-22 problem on abstract data types, which is application vendors now could see a sizable market that they could then insert their code into. It also solved the transaction processing problem. He had a high-performance transaction engine into which we could insert the Illustra extensions. So we set about putting Illustra into their system, and at least for a short while, life was really good. And I'll omit what happened thereafter, which was largely very, very dark. And instead turn to why do I bother to tell you a bicycle story? Well, the first reason is to prove to you that I can write an algorithm. So if you want to ride across the country, it's really pretty straightforward. You get up in the morning, you ride east, and you overcome whatever obstacles come up. And if you persevere long enough, you're clearly going to get to Wollaston Beach. So that's an algorithm for accomplishing a cross-country bike trip. If we abstract this a little bit and say, take out ocean and put in goal, and take out ride east and put in action, then we have an abstraction, which is until you reach a goal, get up in the morning, make an action that moves you toward your goal, persevere, and overcome whatever obstacles come up. And that's a fairly general algorithm for accomplishing a goal. So we'll turn this into a macro, which I will call make it happen. So the bicycle trip is about make it happen. So the second thing to ask is, why would anyone in their right mind want to ride across the United States, let alone two people with advanced degrees in computer science? It's long and hard. North Dakota is no fun, no matter what. There's periods of depression, occasional elation, and a lot of monotony slogging through the swamp. So why would anyone in their right mind choose to do this? So if you want to look at my resume, my point of view is, so I have a PhD, as do many of you, or it's in process. From my point of view, getting a PhD is a lot about make it happen for about 5 years. There's certainly periods of depression. I flunked orals the first time. Getting a thesis that your supervisor will agree to sign is not much fun. So you're into make it happen for about 5 years or so. Following that, I took a job at Berkeley, as DeWitt pointed out. Getting tenure at a university is a lot about make it happen. Every time your paper gets rejected, that's gloom and doom. Every time one gets accepted, that's elation. And a lot of it is slogging through the swamp for about 5 years. So make it happen is also about riding across the country. It's only about 2 months long. So there's an obvious conclusion to be drawn, at least in my opinion. Clearly, I look for make it happen opportunities and then try to accomplish them. So the third reason to talk about a bike trip is it's a metaphor for building large system software. So to build Postgres, what do you need? You need to start with a good idea, which I'll come back to in a minute. After that, we built a prototype for somewhere around 5 years, and a lot of that was make it happen. The good ideas, some of them worked, some of them didn't. Some of the decisions were good, some of them were bad. We had to fix the good ones, we had to fix the bad ones, leverage the good ones, and always had to remember that it was never too late to throw everything away and start again. Well, then you get to where you can start a company. So then you have to hire superb implementers, people like EMP1, the Quiet One, and Triple Rock. Hire talented executives, folks like Uptone and the Voice of Experience. And then there's make it happen with its associated ups and downs. And a lot of it is a long slog through the swamp. So abstracting this a bit, this is have a good idea and then make it happen for around 10 years. So what do you do for a decade? I built Postgres. And you can say immediately, why in the world would anyone in their right mind want to do this? This is just too hard. It takes forever. It has lots of ups and downs. It's worse than getting tenure. Well, I think you know the answer, which is it's the same as the bike ride, which is that's what I do. So now how do you come up with good ideas? Because if you want to get anywhere, you've got to have good ideas. Some people say, well, I go off onto the mountaintop and I think, and good ideas come down from somewhere, and that's how it happens. I've never had any good ideas doing that. I love to go off and hike, but it's not to get good ideas. Instead, what I recommend for coming up with good ideas is talk to real-world users. And when you get done doing that, talk to some more real-world users. You can never talk to too many users. In general, they will be happy to tell you exactly what they like and don't like. And if you can figure out how to solve their problems, that's a really good start on good ideas. In addition, hanging around a critical environment who will ruthlessly attack your ideas and make you turn them into better ones is really invaluable. So MIT and Berkeley and other places are just great environments of smart people who will ruthlessly tear you to shreds. Now, some people have said a Turing talk should be about what I think are good ideas right now. And I did give such a talk. There's a test of time talk in ICDE of this year. So if you want to know my thoughts on what are good ideas, go look at that website. So now I want to just close with a few thoughts. First of all, where does make it happen come from? Because in my experience, you don't have much chance of getting a PhD or getting tenure or writing a big complicated database system or writing across the country without a big dose of that stuff. So my wife told me I had to say I have no idea. It's certainly way above my pay grade to delve into this sort of psychology. Second thing is, what about serendipity? It was really important in Drake, North Dakota. I'm not sure we would have gotten across the state without my brother being around. It was really important to Illustra. If Uptone hadn't repositioned the company on a dime, we'd have never made it. It's often a very, very significant factor and shouldn't be underestimated. Sometimes you win, sometimes you lose, but there's a huge amount of variance caused by luck. Bad luck also happens. If the elephants come along and do roughly what your startup is doing, you're toast and there's not much you can do about it. So bad luck also can be as influential as good luck. And it's simply a random variable. It shouldn't dissuade any of you from starting a company if that's what you want to do. Okay, now most stories of this sort sort of close with what's happening present day. So fast forward about 20 years. So our bicycle sits in our basement gathering dust. My wife keeps saying every time we move that we should get rid of it, and I keep refusing. It has not been ridden since Wollaston Beach. I still love taking on physical challenges, most recently climbing all the 4,000-foot mountains in New Hampshire. Illustra was successfully integrated into the Informix code base. It's still available from IBM, which purchased Informix in 2001, I believe. Postgres abstract data types, roughly what I've talked about, have been added to most relational database systems by now. This is considered table stakes for most relational systems. The biggest impact of Postgres probably came from a collection of pickup folks who took the open source Berkeley prototype in 1995, which had been converted from Quell to SQL, and has been shepherding that open source system ever since. This collection of folks has nothing to do with me or Berkeley, and has just been pure serendipity and is an example of open source at its best. Postgres has formed the starting point for several DBMS startups, including Greenplum and Netezza, and the fact that it's freely available has facilitated a whole bunch of parallel database systems. My daughter Leslie is currently the social media director for a startup in New York City, and believe it or not, that company uses Postgres as its underlying database system. I'm still building new database systems. In the past decade or so, there's been CStore, which turned into Vertica. There's been HStore, which turned into VoltDB. There's been SciDB/Paradigm 4. I could have used any one of those three systems as the example to run along in this talk. Each one of them took a decade. Each one of them had a lot of ups and downs, and the details would have been different, but each of them has been make it happen for a decade or so. Now, I want to end by mentioning that Postgres was in fact written by 39 Berkeley students and staff with a bunch of collaboration from Larry Rowe. And here are the 39 of them on this slide. I was told I should have put everyone's picture in here instead of just their names. I couldn't find enough pictures. There's some notable folks here. Joey Hellerstein, who's in the third row. Marty Hurst is also on the faculty at Berkeley. Mike Olson is the big kahuna at Cloudera. It turns out that Marcel Kornacker is the chief architect of Impala. And so a lot of the people who wrote Postgres have gone on to do very illustrious things. And I'm really proud of all of these folks. And without these students and staff, Postgres would have never existed. I'm also, none of this would have happened without some incredibly talented system programmers, people like Emp1, Triple Rock, and Quiet One, Short One. It turns out that commercializing, prototype database systems is just a huge amount of work, and it requires you solving some really hard problems. You may have heard of Jim Gray talking about Heisenbugs and Bohr bugs. Heisenbugs are ones you can't reproduce. Those are the hardest ones to find, and you put talented system programmers on airplanes to go to important customers who are having Heisenbugs and try and figure out what the heck is going wrong. I'm just in awe of people who have the skill to do startup system programming. Startup executives, people like Uptone, Smooth, and the Voice of Experience, who can take these very fragile startup companies and navigate them through very choppy waters, avoiding the wake of the elephants when it comes up. I'm especially indebted to Q-Ball, who is a current partner in the Boston area, who has been the CEO of multiple of my East Coast startups. And then none of this would be possible without capital from the land sharks. I'm not a fan of mortgaging my house to try and do a startup. I'm especially in debt to a man I call the Believer, who has financed multiple of my East Coast startups. None of this would be possible without my wife and family. Here on the right, you see my daughter Leslie, 27 years later, who you last saw in Winthrop, Washington, along with my younger daughter Sandy. I'm especially indebted to my wife, Beth, who not only had to spend 2 months looking at my back as we rode across the country, but has to deal with my goal orientation, my incessant desire to start new companies, and I'm sure she doesn't realize that she is singularly responsible for keeping me from falling off a bunch of my own personal cliffs. And if you want to stand up, my wife back. And lastly, the 1998 Turing Award winner was Jim Gray, pictured here hiking in the Sierras. Jim was lost at sea 8 years ago, and I think I speak for the entire database community when I say, Jim, we miss you every day. Thank you very much.
So you generalized your bike across the country, and one of the things you did is you generalized head east to take action, or action. The head east part was pretty easy to figure out. You have any advice for how do you figure out what the right action to be doing at any morning is?
I mean, sure. So the easy way to answer that question is to say if you want to do a startup, I think there's a fairly standard template that you have to go through to do it. You have to have a good idea, you have to build a prototype, you have to find the first few customers, you have to hire at least one executive, and then you have to try and raise more money at higher valuation. So I think in doing a startup, there is a fairly obvious next step. I think if you have a good idea and you're trying to build a prototype, when Gene Wong and I started building Ingress, we had no idea how to build a database system. We just started doing it. And you make mistakes along the way and you learn from your mistakes. So the answer is just start doing it. Do something. I think the worst mistake people make is they have an idea and then they kind of sit on their hands because they're not sure if it's a good enough idea. And just start building it, and either your idea will get better and you'll throw some code away and redo it, or it will turn out to be a really good idea and you'll be way ahead of where you were before. So I mean, just do something. Take some action.
Hi, Mike. Congrats again. Great talk. I'm sure there are lots of people in the audience, especially the youngsters, who might be wondering, after listening to all this, what should they do once they leave school, or even, already working people who are wondering, what should their life trajectory be in terms of professional career between, for example, going to universities to become professors versus joining small companies versus big companies and so on. So what sort of advice and, rule of thumb, whatever modus operandi to make that call?
You guys ask hard questions.
You're supposed to give all the wisdom, right?
So I think, big companies don't innovate in general. There's some exceptions, but by and large.
Okay, now you're going to make me go for a long time.
Big companies innovate by buying startups, by and large. Now, there are a bunch of exceptions, which is, companies started in the last decade, like Google and Yahoo, are still innovate. But I think traditional companies don't really innovate. So I think going to work for a traditional bricks and mortar big company, you're not going to make a big difference. You're going to be in a political environment where whatever you do, the odds are that forward progress is going to happen from buying something else. So I'm a huge fan of going to work for startups these days, they pay absolutely competitively with big companies. And if they fail, you've gotten really good experience and you go on and do something else. In terms of joining a research lab versus going to work for a university, I think the advantage of a university is you're forced to be an entrepreneur. You're forced to go, say, at MIT, the MIT Corporation does not pay my telephone bill, does not provide me with office furniture. I have a hunting license to go hustle, and I think that makes you lean and hungry and very aggressive. And I think, research labs don't have that forced entrepreneurship in them. And so I think if you want to be an entrepreneur, try out academia. If you want to not have to be subject to all that stress, and it's really stressful, then go to work for an industrial research lab.
Thank you. That was at least it was a fair description.
So, Mike, the hero of your story was not Mike Stonebraker. Right? The hero of your story, at least the way I heard it, was Uptone.
Was what?
Was Uptone. The guy who turned the company on a dime to sort of reposition Illustra for for the database of the internet. And I think that's true in general. I think many of these tech companies, yeah, I mean the technology is important, and in general, the good companies will have good technology. But maybe even more important than the technology is the positioning of the technology and the packaging and the understanding of the use cases and sort of building it for a particular and popular use case. So I guess I was wondering if you could talk about does it matter? I mean, how much does technology matter, and how much does marketing matter, and how much does understanding use cases matter? And is it fair to say that Uptone was more important to Illustra's success than you were?
Okay, so I think the simple answer is that if you want to get venture capital, you need a good idea, and you need a prototype, and you need an engineering team. And so I think to get going, it's a lot of engineering, and that's where it matters a lot. I think subsequently, marketing is hugely important, and I think startup executives make a huge difference. That's why they get the big stock options, and their impact cannot be underestimated. I think it's pretty clear. I mean, you can go through example after example where the better product doesn't often win. It doesn't inevitably win. I mean, it was in 1984. It was well understood that Ingress had a much better product than Oracle, and Serendipity, anti-Serendipity, which is the IBM released sequel, and Oracle jumped on that bandwagon very, very adroitly, and Ingress had Quell, and that was kind of the end of the story. So I think serendipity is hugely important. Marketing is hugely important. That stuff cannot be underestimated. But you can't even get there unless you have a good idea.
So overall, what's the ranking? I mean, how do you rank the? I mean, like, it's a very vague answer. I feel unsatisfied. What's more important, technology or marketing?
Hi, Mike, can I ask the next one? Okay, Mike. I actually am a co-founder of a company in the database space called Aerospike. So a lot of the things that you talked today resonated a lot with me, having duked it out 6 years with the VCs and the customers. But I have a question for you. The question is, so you talked about the large companies not innovating. I think it's really incremental innovation that large companies do. Disruptive innovation is something they cannot do. But do you think that there is a way anybody can escape as a database company and become the next Oracle? And which is not Oracle, of course. But Is it not even possible anymore, given the whole ecosystem and the money involved, compared to what happened with relational databases? Multiple companies came out big, and then Oracle and a few of them consolidated. What is your thoughts on that?
I mean, I think the landscape is littered with big companies that have failed. Look at AOL. The landscape, the landscape is littered with what are called unicorns in the venture capital world, which is startups that have $1 billion valuation. Think Hortonworks, for example. And I think there are lots of cases where the big incumbents don't necessarily win, although they do have a big advantage. And so I think, do I think in the database space there's going to be the deck chairs are going to get rearranged? I wouldn't be surprised at all. I think the impact of the quote Hadoop, end quote, the impact of Spark, the impact of new hardware. The thing that's really, really nice is that the hardware rules keep changing, and startups can adapt. The only advantage startups have is they're quicker than big companies. And so if they can adapt fast and have shrewd marketing, then I think they definitely can flourish.
Okay. Thank you. Gives me a little bit of hope.
But from my point of view is that if you have a good idea and you want to prove that it's a good idea, you have to do a startup, because otherwise the rubber is just meeting the sky. But only do it if you make it happen in your blood, because it's too much work otherwise.
Hi, Mike.
Hey, Don.
That was a wonderful talk, Mike. Thank you. My question is about the history of Postgres. Why did update always fail?
Why did what?
Why did update always fail as a means of protecting referential integrity and other purposes?
I couldn't figure out how to make it do the six cases of referential integrity. And I don't remember which ones it failed on, but I couldn't figure out how to do them all, which was the litmus test for. Because if you can't do all 6 cases, then you need something else to do the rest. And you don't have a single rule system anymore. Well, the answer is you needed a more complicated rule system than the always command.
So first of all, thanks a lot for the great talk. So I'm a grad student, and I'll be asking a question regarding that. I didn't find anywhere in your talk that you mentioned about your grad life. So my question is, do you have a single rule of thumb, like how to survive in a grad life?
Okay, I'm having a hard time understanding you. Could you try talking slower?
Oh, okay, sorry. So first of all, thanks a lot for the great talk. I'm a grad student. In the talk, I did not find any reference to your grad life. My question is, do you have any single rule of thumb how to survive in a grad life, like grad student, being a grad student and all?
How to survive grad school?
Yeah.
Okay, so personally, I think the most important thing, the way I see the most common failure pattern I see among grad students is you start off working on X. In 6 months, you decide, oh, that's not a very good idea. So then you switch to doing Y. You work on that for 6 months. You decide that's not a very good idea, and then you switch to doing Z. So pick something, and then run with it. Because I think if you keep switching what you're working on, you'll never get out. So that's number one. Number two is pick a thesis advisor with a track record of getting students out in a modest amount of time.
Thank you very much.
Okay, so this is a bit light for our final question, but might as well. You mentioned elephants to describe the big corporations. Does this have anything to do in any way at all with the fact that Postgres' current logo is an elephant head?
No.
Dave, I have a light-headed, a light comment and an anecdote that Mike came to visit SDC, where I used to work in Los Angeles. I don't know if you remember that, but at the end of the visit and so on, he looks at me and says, "What the hell are you doing here in this flat domain, no mountains, nothing to do? Why don't you come to the Bay Area?" I don't know if you remember that, but that sticks in my mind, and I ended up in the Bay Area, ended up in Berkeley. So my question to you is, after you found Berkeley so wonderful, why did you move to MIT?
I'm not allowed to give the. I'm not. I think. Let me answer with a statistic, which is, from the time I started the first company in the Bay Area until I left was 19 years, and I started 3 companies. From the time I started the first company on the East Coast until now has been 11 years, and I've started 6 companies. So I think one way to, the statistics don't lie, that you know, a change of pace was hugely beneficial. So I think that's a benign answer, right?